Welcome to our series on quadratic equations. Now, in this particular video, you will understand my innovative way of finding quadratic equation in standard form from given complex roots. Complex roots will always be given in conjugates, right? We have four examples here, question 1 to 4, where we have taken different types of combinations which should cover all what you need. Now, the beauty is that I'm going to share with you my method, which is most efficient way of doing it, not really taught at schools or in the books. So I hope that method will help you to solve such questions very easily. Means mind blowing. Correct. So let's begin with the solution of question number one. And after that, don't forget to provide solutions of the next three questions. That is, improvising the learnings which you get. Hope it makes sense. Great. So let's begin our solution. And what you are going to see or witness just now will be amazing solution with which even the brightest of the students and teachers will get shocked. The problem here is to determine the equation of quadratic relation in standard form and vertex form of the quadratic relation that has zeros at 2 plus square root 3i and 2 minus square root 3i. I am Anil Kumar. Welcome to your YouTube channel, absolutely free for the last 15 years, where you provide me with problems and I give you solutions. Perfect. And these are some of the amazing solutions. Many of you must have come across this kind of a question, and a couple of ways you do is adopting the formula that if x1 and x2 are the roots, then the equation will be y equals to x minus x1 times x minus x2. And of course, multiplied by a, right? Now, that could be one equation which will give you roots. However, this is not a very simple one. If you use the standard technique, you will come across this as x minus. So let me do 2 minus square root 3 I, right, times x minus 2. And when you do minus of this, it becomes plus square root 3 I times a. A could have been written in the beginning also. Now, look here. We have three terms, and when you multiply 3, you got nine terms to simplify, and that too with the complex number I and square root. So, irrational numbers combined. So, if you follow this procedure, of course, you will get the solution. 90% chances are that you are going to make calculation mistakes. So, I will recommend to avoid this strategy. Perfect. So, this is the strategy normally used in schools, should be avoided. So, avoid. So, what should you do? Now, here is a very cool way of doing it. All my students adopt this strategy, and their teachers are always shocked year by year after year. So, let's go to some foundation of how do we find the quadratic equation and its roots. If you have a quadratic equation as y equals to ax squared plus bx plus c, then you know that the roots are what? So in that case, roots will be, you can calculate using quadratic formula, x equals to minus b plus minus square root of b square minus 4ac, right, over 2a. So that is the formula, right? Now think a bit more. You are already given the roots, and your roots are what? Well, your roots are 2 plus or minus square root 3 I, correct? See, when you have the roots and the equation, you can directly relate them. Let me make it more simple, or we could write this as something over 1, right? Why did I do so? Well, so that becomes easier for you. Let's try to match the numbers. So minus b is equal to 2, right? So let me write down minus b equals to 2. That means the value of b is minus 2. See, without doing any calculation, directly we found one of our coefficients, right? That is, in the equation ax squared plus bx plus c, we got the value of b precisely. You get the idea, right? That is the power of this approach. I hope you're getting it now. Well, not only that, 2a is in the denominator. So now let me put 2a as equal to, there the denominator is 1, and so a is equal to half. So we get the other leading coefficient, which is a, and that should be just half, right? So we got that also. How do we get c? We're going to get c by looking at the term within the radical sign. And in the radical sign, you see b squared minus 4ac, right? And that should be equal to this one. In the radical sign is 3 and what? I square, which is minus 3. You get the whole idea, right? Now you know what is b, what is a. Only thing which you need to find is c. Very simple. Let's substitute. So b is minus 2. That's right. Minus 2 square minus 4 times a is half. And c we want to know. Perfect. So which is like 4 minus 2c, right? Equals to minus 3. You can rearrange, right? 4 minus 3 comes on this side, 2c that side, correct? So you get 7 equals to 2c, and you know what? C is 7 by 2, right? So c is equal to 7 by 2, right? So we can write here c is equal to 7 by 2. Makes sense. Once you find all these coefficients, you can write down your equation. Y equals to half x squared minus 2x, and c is 7 by 2. Do you see that? That becomes your equation in standard form. You get the idea, right? It's so simple as that. Now, writing in vertex form is very simple. You can actually uh, take care of half here, right? And you get what? X squared. You get here minus 4x, right? And there is a plus here. I forgot to write that. And then you can keep this 7 by 2 outside and continue with your completing the square, which you know, right, at this stage. So you can complete this and get the vertex form of this equation also. However, what you need to appreciate is how easily, without actually multiplying those trinomials, we got our equation, the simplest of the calculations. This is the technique which you should be adopting, right? And that is the reason why my students are right there on the top. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. And keep sharing problems to get the right solutions. Great. All the best. Follow my book and bring alive the real experiences. Thank you and all the best.